Assalamu alaikum dear students. Today our first lecture, and in this lecture we will try to have a brief introduction about this course and about the course contents and about the scope of this course. So this course titled as Physico-Chemical Processes in Water Treatment is basically a course which is going to describe all the processes uh, which can be physical or chemical which are taking place in the in our treatment systems, in our water treatment systems, in our wastewater treatment systems, in both. So we will be uh, more discussing about the uh, nature of the processes, which will include the procedures and different processes and their mechanisms and their kinetics, and how those components are actually taking place, and how those processes are actually involved in the whole treatment process. So it is not going to describe some treatment methodology, but it will be trying to explain the processes which are actually involved in that treatment. So we will be digging out in depth the details of the process. So it will be more in depth, and it will be more related to the theory and mechanisms. So it will be it will be explaining the processes in detail, how the different treatment processes will be taking place. So generally in this course we will be talking about the different procedures, and so the course outline, first of all, the learning objectives: to understand the fundamental principles of water treatment, to design a full-scale water treatment plant for potable supplies. And the contents will be including the introduction to physico-chemical processes, stoichiometry, chemical equilibria, kinetics, reactions, reactors and reactors theory, selecting source and appropriate treatment techniques, coagulation, flocculation, sedimentation, filtration, disinfection, adsorption, ion exchange, membrane processes, sludge management, removal of inorganics, organic removals, and practical work will be including the reaction kinematic studies due to involvement of foreign materials in wastewater, then some of the case studies, and then determining the physical and chemical parameters for water bodies affected by the environmental degradation. So it will be some field work which you will be doing. So these are the books. I think any standard book can be used for understanding the physical processes, because basically these processes are the conventional mechanisms, so it can be obtained from any standard book. So you can follow any book. Metcalfe and Eddy will be a more preferable book for wastewater engineering. It covers all the topics, and we will be doing some assignment work, 4 assignments, and one research paper presentation is required, and viva will also be conducted. Introduction to the course and its significance: why we need to treat water, and what kind of our sources are, how we need to deal with these methods. If you consider a water treatment process or wastewater treatment process, basically it includes different components of the steps. It includes physical processes, it includes mechanical processes, it includes chemical processes, it includes microbial processes. All have their own significance. For example, if you study a treatment plant, so how the treatment actually starts. So if you first of all you will come across the term preliminary treatment, and that preliminary treatment is about the physical removal of all the floating materials and foreign bodies in our water and wastewater whatsoever is coming in. So first of all we need to remove those unwanted solid materials which are coming along with the water body. So this is one step, first step, that is called preliminary treatment. And then after preliminary treatment we move forward to physical treatment, and then we move to the chemical and biological treatments. So first of all we have a primary treatment, and then we have a secondary treatment, and then thirdly we have a tertiary treatment, advanced treatment. So how you will differentiate these three phases? First of all we are talking about the primary treatment. So this primary is actually including the preliminary treatment, in which we will be removing the floating bodies, floating particles. So how we will be removing these particles? We will be doing it by the process of screening, and then we have a sedimentation process, which is also a very significant process. So these are the included in the basic primary treatment processes. And then we have a biological activity which will be called secondary treatment, in which we are going to have some biodegradation. And if you consider the biological treatment plants, you will come to know that we have a series of ponds which will be called as stabilization ponds, and those ponds will be related with the microbial activity. So different kinds of microbes will be playing their role in the removal of the most of the organic content and inorganic content, and all kinds of wastewater constituents. So this was something about the uh, different processes. And then we have a tertiary treatment, that is called advanced level treatment. So now that advanced treatment is specific for the uh, particular removal of the toxic chemicals. So that includes some refractory organics, that includes some persistent organic pollutants, that includes some of the uh, um, non-biodegradable organics. So all those categories which need some specific treatment, some special treatment at advanced level, those are called, those are dealt in this tertiary treatment. So uh, back to the topic, we are going to deal with different kinds of treatments, different kinds of processes: physical, chemical, biological, mechanical. So all have their own significance. It all depends what kind of treatment we are requiring, what level of treatment is required. So normally in our country, if you observe, we are satisfied with the primary treatment, that's all. So basically what it is going to do, it will be having a just simply removal of the water bodies, clearing the solid component, and then the sedimentation process, which will be settling down the organic contents, and then it will be disposed this effluent will be disposed into the water bodies. So this is the simplest form of treatment which we are experiencing in our country in most of the cases. But if you move ahead some, maybe you come across some of the secondary level treatments in which we will be dealing with microbial activity. We will be growing that activity, microbes which will be playing their role in the degradation of the uh, biodegradation of the wastewater constituents. So this is how we will move forward. So we have a screening, we have a sedimentation, and then we have filtration, we have this uh, chemical activities which will be including coagulation, then we have flocculation, then we have precipitation, we have filtration. So all these are different kinds of processes, sometimes physical and sometimes chemical. Now we will be talking about the sources of the pollution. Then we will talk about the characteristics of the source, water and wastewater. Then what type of treatment is required, and then what kind of processes will be involved in that treatment. So that's how we will proceed in this course. And then ultimately we will have some advanced topics as well, which will be talking about the stoichiometry, which will be talking about the reactors, which will be talking about the kinetics in that reactors. So all these are a bit advanced topics in which we will be trying to quantify what kind of equilibrium is required within a system, because there are different in every process there are different uh, constituents involved. So every constituent will be having its own configuration and quantity which will be used. So we will try to create a balance in the input materials and in the output materials. So we will talk about it in our coming lectures, in our stoichiometry lecture, in our uh, kinetic reactions, kinematics of the reaction. In that lecture we will talk about it. So in journal we will be today discussing what kind of sources we have and what kind of wastewater characteristics we normally deal with. It is very important to know the characterization, because based on those characteristics our treatment procedure is concerned is so we will be designing our treatment plant based on the inflow in incoming constituents. So wastewater characterization is very important step in determining the designing procedures. So if you just for your uh, revision, what kind of pollution we deal with. So water pollution, normally we have different kinds of sources, we have different sources. So water coming from the pollution from the industries, water coming from the domestic sources, water coming from the storm water, all these are called wastewater. So when we talk about wastewater, it is actually that kind of water which is unwanted and it need to be disposed of. Now we have one source of water, maybe in the form of surface water or in the form of groundwater. And when we are allowing our polluted water coming from the industrial sources or from the domestic sources, it is going to enter into these water bodies. Ultimately, the whole configuration and characteristics of that main source will be affected. Now it depends what is the quantity and proportion of that effluent being entering into this water body, and then how we will be dealing with it. Now if you see here, we have some sources like industrial sources, and normally what possibly can be the sources of environmental pollution. Well, we normally define pollution as addition or subtraction of any component of the system, and any addition will be causing an unbalance. So, this unbalance will be leading to the degradation of the environment. Now, this degradation will be causing an unbalance in the environmental system. So, these are the three steps which will be taking place in this case. So first of all, we will be having a source which will be entering into into another system, and when it enters into another system, it actually disturbs uh, the balance, and it is actually going to uh, degrade that environment. So this degradation is actually a result and consequence of the unbalance created by the addition or subtraction of any kind of constituent into the system. So what kind of unbalance we can cause? Firstly, we have some natural sources, and then we have some anthropogenic sources. So naturally there is some addition or subtraction maybe coming from the uh, naturally existing minerals, or naturally existing dust particles, or maybe volcanic eruptions, or so there are some natural means of addition of these chemicals. And similarly we have some anthropogenic sources as well, which are coming from some man-made source like industrial pollution, like municipal wastewater, like some domestic activity. So all these are actually anthropogenic sources adding up into the system. Then we have another category to explain the sources of pollution, and that is point source and non-point source pollution. I think you can easily distinguish between point source and non-point source pollution. So what is a point source pollution and what is a non-point source pollution? Please just recall yourself and try to explain what are these sources. So actually these sources uh, reflect our source of contamination. If the point if the source of contamination is well known and specific, it will be called point source. So these are some of the examples. So what is a point source? With a known source and specific source, we will be calling it a point source. For example, we have a drain coming from an industrial source, it will be declared as point source. Similarly, if we have some industrial discharge, it will be again a point source. And then the leachate from a landfill or a dump site, it is also known as a point source. So in any case of end of pipe treatment, we are going to have a channelized flow. It has a distinct source. You can identify the source and we can control the source. So all these categories and characteristics define that the source is a point source. So that's why we call it a point source. Then we move to non-point source. So firstly, if we talk about a point source, you should be clear that the source of this point source is well known. The quantity can be determined and the location can be specified. So first of all, we need to have a category which is actually defining from where this waste is coming. That is called a point source. Take the example of this landfill. Can you specify which direction the contaminant can travel from this landfill? In this case, please check this leachate plume. This leachate plume is actually developed due to the higher concentration of some of the contaminants. This leachate plume has developed due to the presence of higher concentration of the contaminants. It will start from this landfill site and it will develop the contours in the direction in which the groundwater will be traveling. The farther you will go, the lower the concentration you will obtain, because the higher concentration will definitely be existing nearer the solution, nearer the source. And then as you move forward, as you move away from this source, the more you go farther, the lesser will be the concentration. So this leachate plume, these contours, if you can see these circles, these lines which are indicating the contours, so in here nearer the source it will be of higher value, of denser value, and the moment you will start moving away, this plume will start uh, diluting and it will become thinner, so the concentrations will start diluting. So this is how we can identify the source and how we can determine this source. So there are two methods. First of all, you can have uh, the monitoring wells installed at different points on this side, and similarly you can have some uh, uh, monitoring wells on the other side as well. So taking the samples from those monitoring wells and then analyzing those monitoring wells, it will be uh, giving us an indication what is the concentration of the contaminant in each monitoring well. So we can determine the first of all we can determine the direction of the uh, movement of the contaminant, and then it will also indicate the level of concentration in each well and how with the uh, distance this concentration is changing. So again this is the same thing, you can go through it, and this is something which is going to give you a profile, soil profile, and it will be defining how the uh, contaminant is traveling in this soil profile, starting from the top layer which will be having an organic content, then the second layer which will be silty, and then we have a loamy line, and then we have studied this soil profile in our previous course, and in this course you can observe that all the kinds of contaminant is going to move downward. So this is how we can locate what is the source. Similarly, if you take the example of this landfill waste, the waste will be traveling in the vertical direction, moving into this setup, this soil profile, and when the contaminant will move in this line, it will ultimately join the water table, and along with that water table the contaminant will travel to the farther distances. So this is how the point source can be identified, and then we can understand the mechanism of the movement of contaminants, so we can trace back the source of contamination. So when we will be able to trace back the source of contamination, it means that we can reduce that source, we can reduce the contamination. So what are the salient features of this point source? It is generalized flow, it has a distinct source, you can identify that source and you can control that source. Now if we move forward to non-point source pollution, you can understand that it is a non-specific source location. For example, acid mine drainage. So as this mines are spread all over in an surface wise location in an area, so you cannot specify what is the location from where it is originating, because it has spread out in two dimensions. It is not a channelized flow, it is a surface flow. When we talk about a surface flow, it has two dimensions, so you cannot go back to single location. So in this case we will be having something like this. So this spreading of the contamination as shown here in red lines and dots, this is showing the spreading of the contamination, which is area wise. When we talk about area wise, it is creating a sheet flow, surface runoff flow. So this will be actually, and similarly agricultural runoff is again an example of the non-point source. uh, when when we talk about the agricultural runoff, it means that when we are supplying water, when we are supplying the fertilizer, when we are having pesticides, its effect is being percolated into the soil and mixing with the surface runoff and then being carried to the farther places, so we cannot relocate from where it has originated. सो अगर हम बात करें इस फर्टिलाइज़र की वजह से जो कंटेमिनेशन हो रही है, या जो कि पेस्टिसाइड्स की वजह से जो कंटेमिनेशन सॉइल लेयर्स के अंदर पेनिट्रेट करती है, और उसी वक्त हम देखते हैं कि जो सरफेस रन ऑफ है जो कि फ्लड इरिगेशन की वजह से हो रहा है, इट विल बी कैरिंग दिस कंटेमिनेशन टू द फर्दर प्लेसेस. इसकी वजह से ये जो कंटेमिनेशन है ये बहुत दूर के एरियाज़ तक मूव फॉरवर्ड करेगी. एंड बिकॉज ऑफ दिस मूवमेंट हमारा जो कांटेक्ट है विद द सोर्स, इट विल बी नो मोर अवेलेबल. सो इसलिए क्या होगा, वी विल नॉट बी एबल टू डिस्टिंग्विश व्हाट इज़ एक्चुअली द सोर्स ऑफ कंटेमिनेशन. सो इसलिए वी नॉर्मली डिक्लेयर इट in the form of surface runoff, and again sheet flow is the representation of this non-point source. So sheet flow kya hai? It is actually the surface runoff. Normally it will be a thin layer over the ground surface, and overland flow is also an expression for it. So no identified point where all discharge takes place. So this is the summary. Please focus on this line, no identified point source. अभी हमने इससे पहले जो बात की सरफेस रन ऑफ की इन केस ऑफ एग्रीकल्चरल रन ऑफ, उससे पहले हमने एसिड माइंस की बात की. सो दैट वाज आल्सो नॉट इन आवर अप्रोच टू आइडेंटिफाई द सोर्स, बिकॉज इट इज़ existing in the form of a sheet flow, a surface runoff flow is provided. So source generally cannot be directly controlled. We need to understand this phenomena, and this is the basics of our difference between point source and non-point source. Moving forward, if we talk about the sources of water, how we can determine the quality of water. So in simple words, अगर हम पानी की क्वालिटी की बात करेंगे, we will be talking about the presence of TDS and TSS and some of the ions, metallic ions, which will be causing hardness, because hardness is caused due to the presence of metallic cations जो कि कैल्शियम और मैग्नीशियम की फॉर्म में है. सो वहाँ से हम इसका पता कर सकते हैं कि व्हाट काइंड ऑफ डिजॉल्व्ड आयंस आर देयर जो कि वाटर पोल्यूशन जो है वो कॉज कर रहे हैं. सो व्हाट काइंड ऑफ वाटर पोल्यूशन कैन बी, इट कैन बी सॉल्ट वाटर, ब्रैकिश वाटर एंड ब्राइन. सो इसकी डिफरेंट कैटेगरीज हैं बेस्ड ऑन देयर कंसनट्रेशन. सॉल्ट कंसनट्रेशन की बेस पे हम इसको कैटेगराइज कर सकते हैं. सो प्लीज़, आई थिंक इट्स काइंड ऑफ रिवीजन, आपने पहले भी इसको देखा हुआ है. सो प्लीज़ गो थ्रू दिस कंटेंट बाय योरसेल्फ. And we move forward to the definition. Here is the definition of water pollution, which can be defined as any biological, chemical, or physical change in water quality that has a harmful effect on living organisms or makes water unsuitable for desired uses is called water pollution. So different kinds of pollution जो कि relate करेंगी with the source of pollution. So physical pollution जो कि expressed है in form of color, odor, taste, silt content, turbidity, temperature, all these things are related with the physical pollution. Then we have a chemical source जिसके अंदर we will be having different pH level differences, and then some chemical characteristics related to the organic content, inorganic content, heavy metals, and nutrients and pesticides. And then we will be having biological pollution, which will be due to the presence of biological materials जिसके अंदर microbes involve होंगे, viruses include होंगे, बैक्टीरिया हैं, प्रोटोजोआज हैं, फंजाई हैं, एल्जी हैं, phytoplanktons हैं. So all these are the microbial source, biological sources of pollution in our water bodies or water sources. What kind of water sources we are talking about in this case? We are talking about the lakes, we are talking about the rivers, we are talking about the sea. Now we move forward and just have a look what kind of physicochemical treatment we normally conduct. So physicochemical treatment has a range of process techniques, and the purpose is to reduce the hazardous potential of waste, and then to reuse or recycling opportunities, and then we have some chemical processes in which we transform hazardous waste into less hazardous substances. So what kind of processes these can be? सो इसमें हमने लास्ट टाइम डिफरेंट कोर्सेज में बात की है, पिछली दफ़ा जो कोर्स था उसमें भी बात की थी कि जो टॉक्सिसिटी है दैट इज़ एक्चुअली अ रिप्रेजेंटेशन ऑफ द लॉन्गर कार्बन हाइड्रोजन चेन्स. सो जितनी ज़्यादा लॉन्ग CH चेन्स होंगी उतना ही टॉक्सिसिटी लेवल जो है किसी भी केमिकल का वो इंटेंस होगा, ज़्यादा होगा. So the best approach is to reduce the level is to shorten the chain of CH. कार्बन हाइड्रोजन चेन को अगर आप रिड्यूस कर देंगे into simpler chain, it will reduce the toxicity level. And there are different processes जिसमें हम इसको reduce कर सकते हैं. And one of the processes is called mineralization. In this process we are actually going to break down the longer CH chains into smaller CH chains, which will be having a lesser toxic effect. सो नॉर्मली जो हमारे persistent organic pollutants हैं, polychlorinated biphenyls हैं, डायोक्सिन्स हैं, फ्रियोन्स हैं। इन सब के जो ट्रीटमेंट का जो बेस्ट मेथड है दैट इज़ टू कन्वर्ट देम इनटू simplified CH chains. So we will be having some on-site activity and we will be having some off-site activity जो कि ट्रीटमेंट से लिंक करते हैं एंड स्पेशली जो ऑन-साइट ट्रीटमेंट है इट इज़ अ न्यूअर वर्जन ऑफ द ट्रीटमेंट। ये वो ट्रीटमेंट है जो कि हम डिफरेंट प्रोसेसेस के अंदर ट्रीटमेंट कर रहे होते हैं। So we are actually trying to reduce the contamination sources at the site. इसको हम कहते हैं on site treatment approach and then we have an off site treatment approach जो कि again conventional techniques के ऊपर बेस करती है, conventional approaches के ऊपर बेस करती है और जिसके अंदर हमारे जो जितनी भी approaches हैं वो सारी end of pipe treatment की तरफ हमें लेके जाती है। But when we talk about the on-site, it means we are talking about some approach within the process, some modification within the process. वहाँ पे हम इसको treat करने जा रहे हैं and then uh, some physical processes on site, for example sedimentation treatment may be integrated into manufacturing processes. On site reduces the volume needed to transport and transport cost. अगर हम प्रोसेसेस के अंदर उसी के अंदर ही कोई लूप बना के कोई लूप डेवलप करके क्लोज्ड लूप डेवलप करके जो बाय प्रोडक्ट्स हैं या जो हमारा वेस्ट प्रोड्यूस हो रहा है उसी को हम रिसाइकल कर लें या उसको रीयूज़ कर लें या उसको विद इन द सिस्टम किसी तरह से अडॉप्ट करें दैट मीन्स वी आर एक्चुअली रिड्यूसिंग द लोड ऑन द फाइनल ट्रीटमेंट प्रोसीजर्स। सो सिमिलरली अगर हमारा जो लोड है दैट हैज़ बीन रिड्यूस्ड और that is no more further required to be carried to the further places, treatment plant तक ले कर जाने की ज़रूरत नहीं रही। So that means we are actually reducing the transport cost as well. So these are some of the benefits which will be obtained by on-site treatment adaptation. So you can go through it again. Off-site allows for dedicated waste handling and treatment system. Of course, when we will be having a separate treatment plant and separate treatment and disposal activity, it will be dedicated to the waste only waste handling. It will not be involved in any kind of reuse activity and it will be requiring a high technical skill by the expertise for handling of this waste and so these are some of the characteristics for off-site treatment which you can go through by yourself and then here is some of the situation for the treatment. So again it is all about the off-site treatment. So all these off-site treatments need a huge investment, huge cost is required, huge infrastructure is required and there are so many processes. Finally all the disposed material and even that sludge which will be left at the bottom will be required to be cleaned and carried out and then that sludge will be even required to be disposed into another disposal site which will be a landfill site. So इसमें देखें कि जो sludge है इसको भी आपने collect करना है. We need a separate treatment for that and once that sludge has been dried फिर हमने उसको landfill के अंदर dispose करना है. So it's all about the off-site treatment procedures and processes as well. So इसके लिए we need some separate mechanisms. But when we talk about on-site, again it's an advanced approach and the basic purpose is to reduce the load on the final treatment. और उसके लिए हमारे पास वी हैव सम ऑप्शंस टू रीयूज and to move forward with the lesser treatment requirements. So this was something about the offsite solutions. So what are the physical processes which we are going to study? ये वो फिज़िकल प्रोसेसेस हैं जिनको हमने डिटेल के अंदर डिस्कस करना है इन आवर कमिंग लेक्चर. आज का जो लेक्चर है इट इज़ ओनली बेस्ड ऑन आवर इंट्रोडक्शन. सो इसमें हमने सिर्फ ये देखना है कि व्हाट आर द फिज़िकल प्रोसेसेस एंड व्हाट आर द केमिकल प्रोसेसेस जिनको हम स्टडी करने जा रहे हैं. And then we will move forward with the characterization, and then we will discuss these processes in detail. So these are the physical processes. इसमें अगर आप देखें तो सबसे पहले है separation. Now what this separation means? This is actually the preliminary approach, the preliminary processes जो कि हमने बताया था कि थ्रू स्क्रीनिंग हमने जो फ्लोटिंग मटेरियल है उसको सेपरेट करना है. सो सेपरेशन के लिए भी वी हैव कोर्स स्क्रीनिंग एंड देन वी हैव अ फाइन स्क्रीनिंग. अब उसमें जो कोर्स है उसमें भी जो डिस्टेंस बिटवीन the screens is about 20 to 100 millimeters. This is a standard format for a coarse screening. And for the other method जिसमें हम फाइन स्क्रीनिंग यूज़ करते हैं उसमें जो मैश साइज़ है दैट इज़ अबाउट 10 millimeters. सो अगर हम इन स्क्रीन्स को यूज़ करेंगे दैट मीन्स वी आर एक्चुअली trying to avoid any kind of intrusion of the physical particles जो कि float करते हैं, and then some of the solid waste which is accompanying the effluent, and we are actually limiting the entrance of all these non-required materials. सो इसमें आप देखें अगेन द स्क्रीन साइज़ जो मैंने आपको बताया उसमें भी जो कोर्स स्क्रीन साइज़ है दैट इज़ मोर अप्रोप्रिएट. 20 to 100 millimeter डिस्टेंस बिटवीन टू screens, two screen bars actually. And we prefer to install these bars on an inclined सरफेस. इनको हम किसी एंगल के ऊपर डेवलप करते हैं ताकि इनका जो सरफेस एरिया है वो इंक्रीज़ हो सके, एंड बिकॉज ऑफ दैट इंक्रीज इन द सरफेस एरिया वी आर एक्चुअली ट्राइंग टू रिड्यूस देयर वेलोसिटी, एंड बाय दैट पर्पस वी आर अचीविंग मोर इम्प्रूव्ड स्क्रीनिंग प्रोसेस. जो दूसरी स्क्रीन्स की हमने बात की थी अबाउट दी फाइन मैश वाली जो थी जिनका जो मैश साइज़ था वो 10 मिलीमीटर्स का साइज़ है जो नॉर्मली हम यूज़ करते हैं. उसका जो सबसे बड़ा ड्रॉबैक है दैट्स द कंटिन्यूस क्लीनिंग प्रोसेस. सो उसमें वी नीड अ थॉरो क्लीनिंग and very frequent cleaning is required because the mesh size is very small. In most of the cases we will be getting it clogged. Because of that clogging, the whole procedure of the movement of the flow of the water will be hindered, and it will get choked, and so we must avoid the clogging process. Now that clogging can be avoided if we are using the coarser screens. So that coarser screens का size क्या बताया 20 to 100 millimeter size. Similarly we have some sedimentation process. Sedimentation के लिए भी again we will be having some process: flotation, drying, evaporation, sludge, dewatering, filtration. So this is the सेपरेशन प्रोसेस जिसमें सीविंग है, स्क्रीनिंग है, distillation. So we talked already about this process. We have adsorption process. Adsorption is a physical process and absorption is a chemical process. Please keep in mind. एड्सॉर्प्शन में क्या है कि जो आउटर सरफेस ऑफ एनी कंपोनेंट, एनी पार्टिकल है, उसके साथ कोई भी दूसरा आयन और रेडिकल या पार्टिकल is going to get attached on the surface. So this is called adsorption. सो एड्जॉर्बेंट्स कौन से हैं? इसमें एक्टिवेटेड कार्बन है, अलुमिना है, बॉक्साइट है, मॉलिक्यूलर सीव्स यूज़ होंगी फॉर एड्जॉर्प्शन, सिलिका जेल है. सो हेयर इज़ सम ऑफ देयर एप्लीकेशन, इसको भी आप गो थ्रू कीजिएगा. देन वी हैव सेडिमेंटेशन प्रोसेस. एंड अगेन सेडिमेंटेशन के अंदर हमारा जो ऑब्जेक्टिव है टू settle down the components which are having the particles which are having higher size. So जिनका size high होगा, density ज़्यादा होगी, that will settle down with the movement. So while moving in that sedimentation tank, जितना भी particle है which is having higher density, वो settle down हो जाएगा and it will be collected in the bottom in the form of sludge. So it is another physical process, but later on we will combine this process with a chemical process. So coagulation and flocculation is a combined प्रोसेस जिसके अंदर जो कि सेडिमेंटेशन का प्रोसेस है, जिसमें फ़िज़िकल और केमिकल बोथ एट द सेम टाइम यूज़ हो रहे हैं प्रोसेस. एंड वी आर एक्चुअली स्पीडिंग अप द प्रोसेस ऑफ सेडिमेंटेशन. सो वो हम पढ़ेंगे इन डिटेल जब हम कोएगुलेशन की और फ्लॉकुलेशन की बात करेंगे. बट इनिशियली वी आर ओनली टॉकिंग अबाउट दिस फिज़िकल सेडिमेंटेशन, जिसमें कि हमारे पास एक ही अप्रोच है जो कि डेंसिटी बेस्ड है. एंड इन दिस केस जिसको हम प्लेन सेडिमेंटेशन भी कहते हैं, PLAIN, प्लेन सेडिमेंटेशन, जो कि नॉर्मली कंडक्ट की जाती है इन अ रेक्टेंगुलर सेडिमेंटेशन टैंक. और जो कंबाइंड है उसके लिए अगेन वी विल बी रिक्वायरिंग सम मैकेनिज़्म जिसमें फ्लॉकुलेशन जो है उसको हम फैसिलिटेट कर सकें. एंड फॉर दैट फ्लॉकुलेशन वी नीड सम रोटेटर्स, सो दैट इज़ नॉर्मली प्रेफर्ड इन अ सर्कुलर टैंक.